Hello, in this video we are going to talk about our second section. Okay, our second section is the quantitative analysis of organic compounds. What do you mean by quantitative? Quantitative comes from the word quantity, so it means the amount or the weight of the compound. I want to determine the weight of something or the amount of something. Okay. We are dealing with organic compounds, so we mainly talk about carbon and hydrogen. Okay, so in this section, our aim is to determine the weight of the carbon and hydrogen in my organic compound. Okay, so we will divide our section into 5 main points. Okay, like I said, the first point will be how to determine the weight of carbon, weight of hydrogen, and also the percentage of carbon and the percentage of hydrogen in my sample. Okay, this is the aim of our first point in the section. In order to determine the weight of carbon or hydrogen, I have my organic compound, okay, that contain carbon and hydrogen, and I will heat it in something called combustion train with at 600 to 800 degrees Celsius. Okay, I will heat my compound with something called copper oxide, and this copper oxide is an oxidizing agent, is the same agent that we used in the qualitative analysis. Okay, what we said that all carbon will be converted into what? By the action of the copper oxide into carbon dioxide, and all hydrogens will be also converted into water. Okay, we said that we are working in something called combustion tree. This is the combustion tree. Okay, like this. Here I put the organic compound together with the copper oxide and I heat. We said that two things will be produced. Carbon dioxide is a gas and water is a liquid. So by the action of the gravity, water will get down here. Okay, here we will have the water, and up here we will have, because it is a gas, it will get up, we will have the carbon dioxide. Okay, so all the carbon is converted to carbon dioxide in the upper part here, all the hydrogen is converted to water in the lower part here. What we do before this, we put here in all these places something called, in the upper part, something called strong base. This strong base has the ability to absorb all the carbon dioxide that come here. Okay. Also here we put something called drying agent. Okay, drying agent. This drying agent, of course, has the ability to absorb all the water that comes down here. So this strong base absorbed all the carbon dioxide. This drying agent absorbed all the water. So if I told you that before this process happens, the weight of the strong base, the weight of the base was at first 5, for example, 5 grams. Okay. And after this process, I weighed this part of strong base together with the carbon dioxide. So the weight of base together with carbon dioxide after this process finished is, for example, 11 grams. Can you tell me from this equation what is the weight of carbon dioxide? Of course, it is very easy. I will do this 11 gram minus the weight of the base only to get the weight of the carbon dioxide. That carbon dioxide will be equal to 6 gram. Okay, okay, very good. The same thing I will do it with the water. If the drying agent is the weight of the drying agent before doing this process, before the water comes here, was, for example, 3 grams. Okay, And after this, the weight of the drying agent together with water, let's say was 7 grams. Can you tell me what is the weight of water? Yes, it's a very easy process. I will do this, the weight of drying agent plus water, 7 gram minus the weight of drying agent only, and it will get me the weight of water that will be equal to 4 grams. Okay, very easy subtraction process. So water will be 4 grams. Like this, I was able to find the weight of carbon dioxide and the weight of water. But can I stop here and I can say that I finished my aim? I cannot stop here. Why? Because my aim was to find the weight of carbon and the weight of hydrogen. What I got here, I got only the weight of carbon dioxide and the water. No, I want to know specifically the weight of carbon and the weight of hydrogen, not the weight of carbon dioxide and water. So what I can do? One step last to finish this process. Okay. I want to know how many or what is the amount of carbon that exists in those 6 grams of carbon dioxide. I also want to know how much hydrogen exists in those 4 grams of water. So what I will do, okay, let's explain this. Okay, what we will do now, I will say carbon dioxide, okay, contain how many atoms of carbon? Only one. What is the molecular weight of carbon dioxide? Carbon is 12, okay. Oxygen is 16. 16 times 2 is 32. 32 plus 12 is 44. So I will say 44 carbon dioxide contain, what is the atomic weight of carbon? We said 12. Contain 12 carbon. What is the weight of carbon dioxide? We obtained 6. So 6 grams or 6 contain how many carbons? And we'll do something called criss-cross. Okay. In order to know what x, we'll do 6 times 12, okay, divided by 44 to obtain this x. Let's translate this into an equation to be studied. Very important equation. We can say that weight of what is this x? X is the weight of carbon that I want to obtain. Okay, weight of carbon equal what? Equals this 6. What is this 6? It is the weight of carbon dioxide. Weight carbon dioxide. Okay. Times 12. What is 12? It is the atomic weight of carbon. Okay. Atomic weight of carbon. Divided by 44. What is 44? It is the molecular weight of carbon dioxide. So this is my equation. In order to find the weight of carbon, very important equations that should be studied. And the weight of carbon dioxide will be given in the exam, will be given in the question. Okay, you don't have to calculate it. Atomic weight of carbon, it should be studied, it is 12. Molecular weight of carbon dioxide, very easy to calculate, it is 44. By this equation, we can find the weight of carbon. The same thing we will do in order to find the weight of hydrogen. We will say water contain how many hydrogen are? Water contain 2 hydrogens, not only one, like carbon dioxide and carbon, 2 hydrogen. What is the molecular weight of water? It is 18. Okay, 16 plus 2, 18. What is the atomic weight of hydrogen? It is 1. 2 times 1 will be 2. So each 18 gram of water contain 2 gram of hydrogen. Hydrogen atomic weight is 1, but here we multiply it by 2 because we have 2 atoms of hydrogen in water. Okay. So what was the weight of water? 4 gram. 4 gram contain how many water? And we will do the same thing, criss-cross. Okay. 4 times 2 divided by 18. In order to get an equation, we will say same equation, weight of x, weight of hydrogen, will be equal to 4, that is the weight of water, okay, divide times 2, it is 2 divided by atomic weight of hydrogen. Okay, this is very important, these two. These two is very important, a lot of students forget about it. Here it is 2 divided by atomic weight of hydrogen. We should never forget these two, okay? Divided by 18, it is the molecular weight of water. Okay, this is the equation to find the weight of hydrogen. Like this, our conclusion is that we should study in all what we explained only two equations. The equation of weight of carbon equal like this, and the equation of weight of hydrogen equal like this, and like this I was able to obtain both weight of carbon and weight of hydrogen. Okay, what remains for me, it is the percentage. The percentage is something very easy. In order to find the percent of any element in a sample, very easy equation. Percentage of carbon will be equal to weight of carbon. From where I can get the weight of carbon? From this equation, divided by the whole weight, the weight of sample. Okay, any percentage is the weight of the thing divided on the weight of the whole thing times 100 to get a percent. Okay, very easy. And the weight of sample will be also given in the exam. You only calculate the weight of carbon, and from this equation you get the percentage. Percentage of hydrogen, same thing, weight of hydrogen. From where I can get the weight of hydrogen? From this law, okay, this equation, divided by weight of sample, also times 100. And by this, we, we can obtain the percentage of carbon in my sample and the percentage of hydrogen in my sample. Like this, we finished our first aim. In this aim, we should study very important four equations. First equation is the weight of carbon. Second equation, weight of hydrogen, and we should not forget the two here. Okay. Third equation, percentage of carbon. Fourth equation, percentage of hydrogen. Finally, I want to tell you something. In order to make sure that you are working good and right, after finding the weight of carbon and the weight of hydrogen, you should make weight of carbon plus weight of hydrogen. Weight of carbon plus weight of hydrogen must be equal to the weight of sample that is given in the problem. Also, percentage of carbon plus percentage of hydrogen should be equal to 100. If these two weights, okay, not equal the weight of sample, and if these percentages not equal to 100, so here can be an error in your calculation. So you should repeat your calculation. Okay, the weight of carbon plus weight of hydrogen should be equal to the weight of sample, and the percentage of carbon plus the percentage of hydrogen should be equal to 100. But if you are working very well and your calculations are very accurate, and you cannot find that the weight of carbon plus the weight of hydrogen equals the weight of sample, or those two percentages not 100%, so my compound may contain another element other than the carbon and the hydrogen, and this element will be the oxygen. So if the percentage not equal to 100, and if the weights are not equal to the weight of sample, so my compound may contain another atom. I didn't mention it in the problem, and this atom will be the oxygen, and then I should add the amount of this oxygen. So if the percentage are equal to 80, remain for me 20%. This 20% will be what? Will be oxygen. Okay, this is very important note. We will use it in our last problem in this section. So remember please this note, these percentages should be equal to 100. This weight should be equal to weight of sample. If not, so the remaining is oxygen. Okay, okay. Let's try to solve a problem on this first point. We can open the PDF. Okay, here what we explain, the combustion train. Here is the equations. I told you we should study four equations: weight of carbon, percentage of carbon, weight of hydrogen. Here there is a little mistake. We should put here 2. Remember, I told you atomic weight of hydrogen should be multiplied by 2. So please multiply this by 2. And the equation of the percentage of hydrogen. Okay, let's try to solve a problem. A very easy problem is telling you the weight of sample 9.67, weight of carbon dioxide 26, weight of water 21. Very easy direct problem. He's telling you to calculate the weight of carbon, weight of hydrogen, percentage of carbon, percentage of hydrogen. Weight of carbon, we said by the equation, it is the weight of carbon dioxide here divided by multiplied by atomic weight of carbon 12 divided by molecular weight of carbon dioxide 44 will be equal to 7.24. Okay, very easy direct problem. Weight of hydrogen will be equal to weight of water 21 multiplied by, we said 2 multiplied by 1, 2 multiplied by the atomic weight of hydrogen, so we put 2 divided on 18, the molecular weight of water will get you the weight of hydrogen. I told you after calculating the weight of carbon, weight of hydrogen, if we do this plus this, it should be equal to the weight of sample. Try to do it. 7.24 plus 2.401 will give you 9.67. Okay, so like this I am working very good. In order to calculate the percentage, weight of carbon on weight of sample multiplied by 100, it will get you almost 75%. Also weight of hydrogen divided by weight of sample multiplied by 100, it will get you 25%. If you do the addition of this, 75 plus 25 will be equal to 100. So like this I'm working very good. So very easy direct problem. Okay, okay, like this we finished our first point. Okay, so let's go to our second point. Second part of the section will be a comparison between molecular, something called molecular formula, okay, versus empirical formula. Okay, very important two terminologies. Okay, molecular formula, it is the real form of the formula. It is the real form, okay, and represents the actual number of atoms present in the formula or in the compound. But the empirical formula is totally the opposite. It is the simplest, not the real form, but the simplest form of the formula, and represents the relative number of atoms in my formula. What do we mean by this? Okay, if we get a certain example in order to facilitate it, compound like N-butane. If you have a compound like N-butane, okay, how we can draw this N-butane? It is CH3 attached to CH2, attached to CH2, attached to CH3. Okay, if I told you what is the molecular formula of this compound N-butane, I told you the molecular formula is the real form representing the actual number of atoms. So you'll only count the number of atoms. How many diverse atoms do you have here? You have two atoms, carbon and hydrogen. How many carbon do you have? 1, 2, 3, 4. So C4. How many hydrogen do you have? 3 plus 2, 5 plus 2, 7 plus 3, 10. So my real formula, my actual number of atoms, my molecular formula will be C4H10. This is the real formula. These numbers are the actual number. N-butane, yes, contain 4 carbon atoms and 10 hydrogen atoms. Those are real numbers, okay? But if I told you to calculate my empirical formula, this cannot be the empirical form. The empirical formula, it is the simplest form, represents the relative number. So I should divide these numbers until to get the simplest form. Can I divide those two numbers? Yes, I can divide them by 2. Okay, if I divide those two numbers by 2 to divide on the smallest possible number, 2, I will get C2H5. 4 divided by 2 is 2, 10 divided by 2 is 5. Can I divide C2H5 on another number? No. If I divide by 2, 5, this will be 2.5. I cannot get a fraction. Okay. So this, can I say that this is the simplest form? Yes, this is the simplest form. So this is my empirical formula, representing the simplest form of the formula. And those numbers are not real numbers. We don't have 2 carbon, we have 4 carbon. We don't have 5 hydrogen, we have 10 hydrogen, but they are relative to each other. Carbon 2, hydrogen 5, relative number to each other. Okay, so this is the comparison between molecular formula and empirical formula. In the exam, in the problem, when he tells calculate empirical formula, when I see this, when he tells me in any question calculate empirical formula, I should do two things, or two steps. Okay, first step, I should calculate the number of atoms present in my compound. How I calculate the number of atoms? Very easy equation. I will do the weight of the atom to get its number should be divided by its atomic weight. Okay, I will do this in all my atoms. I will get all my atoms, calculate their numbers by dividing the weight of this atom by its atomic weight. Okay, to obtain all the numbers. After this, after obtaining all the number, I will write a formula by these numbers and dividing this formula like we did here, divide the formula on the smallest possible number. So divide. After obtaining the formula, I will divide it like we did here exactly. This is the formula. We obtain the number of atoms and then we divide it by the smallest possible number. Divide on smallest possible number. Okay. By these two steps, I can obtain my empirical formula. Okay, let's see a problem to try to applicate this in the problem. Okay, let's go to the PDF. And let's try to solve, yes, problem number A. It's telling you that we have 3 milligram weight of sample, 8 milligram carbon dioxide, 5 water. The same as the last problem. He's telling you to calculate the percentage of the carbon and the hydrogen and also the empirical form. We said in order to calculate the empirical form, we should do two steps. First step is calculating the number of atoms. We have here only 2 atoms, the carbon and the hydrogen. And after this, writing a formula and dividing it on the smallest possible number. Let's try first to calculate the percentage. Very easy. First, we obtain the weight of carbon by the same equation. And then we obtain the weight of hydrogen by the same equation. To obtain the percentage, we divide them on the total weight of sample and multiplying them by 100. This is very easy and we did it before. The new thing here is trying to calculate the empirical formula. Okay. How to calculate the empirical formula? We said that first we should calculate the number of atoms. How I can calculate the number of atoms? I told you we do the weight of the atom. The weight obtained by the atom is carbon is 2.42. Okay, so 2.42 divided by its atomic weight will be 0.2 atom. Okay, this is number of atoms. Also hydrogen, weight of hydrogen 0.61. Here's the 0.61 divided by the atomic weight of hydrogen, that is equal to 1. Okay, atomic weight of hydrogen is equal to 1, will give me the same number, 0.6. I've told you what I do after this. I get this number to write a formula. This is the formula, C 0.2, H 0.6. What I do after this, second step, I should divide on the smallest possible number. I will divide both of them on 0.2. Dividing both of them on 0.2 will give us CH3. This CH3 is my empirical formula. Again, very important. When he tells me in any equation or in any problem, calculate the empirical formula, I should do two steps. First step, calculating the number of all existing atoms by doing weight of this atom. How I can get the weight of atom? From those equations. Weight of this atom divided by its atomic weight to obtain the number. After this, I write this formula, and I will divide this formula on the smallest possible number to obtain my simplest formula, is the empirical formula. Okay. Like this, we finished our second point. Problem number B, deleted, please. We will not work with this problem, okay? We will only work with problem number A. Like this, we finished our second point. It is a comparison between molecular formula and empirical formula, and how to calculate empirical formula in an equation, okay? Okay, let's move on to our third point. Our third point, in this point, I want to know how exactly to calculate any molecular weight, okay, molecular weight, and how to calculate any empirical weight, okay, empirical weight. Okay, in order to solve this question, right, in order to calculate molecular weight, I should make sure that I am working with molecular formula, okay. Okay, and in order to calculate the empirical weight, right, I must make sure that I am working with what? With the empirical formula. Okay. Okay. So same thing. Let's try to make an example. The same example is the N-butane. You remember, if I get to you in the exam, the N-butane, I told you, calculate please the molecular weight of the N-butane and the empirical weight of the N-butane. First of all, in order to calculate molecular weight, we should work with molecular formula. What is the molecular formula of N-butane? We calculated before. It is C4H10. Okay, this is what? This is the molecular formula. So from it, I can calculate the molecular weight. How I can calculate it? I work with each atom separately. Okay, I will put like this. Work first with carbon. Carbon. What is the atomic weight of carbon? It is 12. But how many carbon do I have here? 4. So 12 times 4 will be 48. Okay, 12 times 4 will be 48. Let's move to the hydrogen. What is the atomic weight of hydrogen? It is 1. But how many hydrogen do we have? 10. So 1 times 10 will be 10. And I will do 48 plus 10. It will be 58. Okay. So the answer of this question, the molecular weight of the N-butane will be 58. But the empirical weight, I said to you and I told you that the empirical weight should be calculated from the empirical formula. C4H10 is not the empirical formula. How I can obtain the empirical formula? Obtaining the number of atoms. Here are the number of atoms. Here is the equation. So I should divide it on the smallest possible number. We said I can divide it by 2. If I divide it by 2, I will obtain C2H5. This is the empirical formula, and from this formula I can calculate the empirical weight. Okay, how I can calculate it? Work with each atom separately. Carbon is 12. We have 2 carbon. 12 times 2, it is 24. Okay. Hydrogen is 1. We have 5 hydrogen. 1 times 5 is 5. So 24 plus 5 will give us 29. Yes. So the molecular weight of the N-butane is 58, but the empirical weight of N-butane is 29. So wherever he's telling you empirical weight, don't forget to divide your formula on the smallest possible number. If you have a formula like this, C3H8, okay, and he's telling you in the exam, please calculate the molecular formula and the molecular weight and the empirical weight. First of all, this formula like this, if he's not telling you any other thing, it can consider the molecular formula. Okay, I consider this formula molecular formula because he didn't tell me the real compound. Okay, so I will consider the real formula and molecular formula. So if he's telling you calculate molecular weight, I will calculate it directly. 3 times 12 will be 36 plus 8, and it will be 44. Okay. If he's telling me to calculate the empirical weight, I should make sure first that this is empirical form. I will try to divide it on the smallest possible number. The only number I can divide is 3. If I divide by 3, 8 cannot be divided by 3. It will get me a fraction. I cannot work with fraction. So the C3H8 is also the empirical form, because it is the simplest form. I cannot divide on any number. Okay, so this formula represents two. Represents the molecular formula and also represents the empirical form. So when I calculate the empirical weight, it will be the same as the molecular weight. Again, this formula represents molecular formula, also represent empirical form, because I cannot divide on any number, and also 44 will represent the molecular weight and will also represent the empirical weight. Okay. This question is very important, so please try to understand it very well. Like this, we finished our third point. Okay, how to calculate the molecular weight from the molecular formula, and how to calculate the empirical weight from the empirical formula. Okay. Let's move to our fourth point. Okay, our fourth point, it is very simple. Okay, it is an equation on how to convert empirical formula into molecular formula. So this equation say molecular formula, okay, will be equal to empirical formula multiplied by something called n. Okay, what is this n? N is equal to molecular weight divided by empirical weight. Okay, this is a very important equation. Okay, how we can apply this equation? If you calculate a certain compound empirical formula, you found that the empirical formula of this compound is CH3. Okay, and I told you in the question, this molecular weight should be given in the exam. Okay, you do not calculate. You only calculate the empirical weight. The molecular weight is given, and the empirical weight will be calculated. Okay, I told you that the molecular weight of this compound is, for example, we can say 45. Okay, and in the problem you were able to calculate the empirical formula, and the empirical formula was CH3. So the molecular weight is 45. What is the empirical weight? I will calculate the empirical weight from the empirical formula. Carbon is 12, 12 plus 3, 15. What I will do? I will do 45 divided by 15. It will be 3. So n equals 3. How to obtain the molecular formula? I will do the empirical formula multiplied by 3. The empirical formula is CH3. Okay? So each element or each atom in this formula will be multiplied by 3. Carbon only 1. 1 multiplied by 3, it will be C3. Okay? Hydrogen is 3. 3 multiplied by 3 will be H9. So our molecular formula will be C3H9. Okay, very important equation. And now we will solve a problem to apply on this equation. Okay, now let's move to our fifth and last point, a problem of percentage. Very important problem we are going to get now, and we will try to apply all what we studied in this problem. Okay. Okay, our fifth and last point, it is the problem of percentage. We can call it like this, problem of percentage. In this problem, he will give you certain atoms and will give you the percentage of each atom in the sample. Okay, how to solve this problem? We work by certain steps. Okay, so in order to solve our problem, we should work by certain steps. First step, or let's first say we are working with problem of percentage. Our fifth and last point, problem of what? Of percentage. It is the problem when he gives you certain percentage at the start of the problem. First step, we should make sure that the summation remember when I told you when you have any percentage, the summation of this percentage should be equal to 100. And if it is not equal to 100, how I can do what I can do in this case? If it is not equal, if not equal 100, I will add oxygen like we said before, remember in our first point. If not equal to 100, so we'll complete with what? With oxygen, complete with oxygen. So this is our first step. Let's try to make it in our problem. He's giving you carbon 41, hydrogen 7, nitrogen 24. If you do the summation of these, it will not be equal to 100. Or what is remaining? It will be equal exactly to 73. So remaining 27. So look here what he did. He added from himself, 27% oxygen. So you should add this. This is very important step. First step, I should make sure that summation is equal to 100. If it is equal to 100, I will not add any oxygen. But if it is not equal to 100, I will add the rest of 100 oxygen. Here what he did, he added 27 from himself oxygen. Okay, so this is the first step. Second step, to solve this problem, I will consider that all the percentage are grams or are weight. Okay, remove this percent and put instead of it gram or weight. Okay, so all this percent I will remove it and I will consider it as weight. Okay, so carbon is not 41%, it will be 41 like gram for example, and this will be 7 grams, this will be 24 grams, this will be 27 grams. So very easy step, remove percentage and consider them as grams. Okay, third step is to calculate the empirical formula. Remember I told you in any problem, when you see calculate empirical formula, I told you we should do two steps. First step, calculate the number of atoms, weight of the atom divided by its atomic weight. Second step, writing formula and dividing this formula on the possible smallest number. Let's try to do this like we did it in the last problem. Possible smallest number. Okay, so when he tells you in any problem, now I want to calculate the empirical form, I should first calculate the number of all atoms, weight of this atom divided by its atomic weight. Then we write a formula and we divide this formula on the possible smallest number. Let's see here what he did. Relative number of atoms, it is the number of atoms, weight of atom dividing by its atomic weight. How many atoms do I have here? Not 3, we have 4 atoms because I added oxygen. So I will do this with those 4 atoms. Okay, by calculating weight of atom 41 divided by 12, it will be 3.44 atoms. This is the number of carbon. The same thing for hydrogen, it will be 7. The same thing for nitrogen, and remember atomic weight of nitrogen is 14, and the same thing of oxygen, and those are the number of atoms. What I will do after this, I will write an equation by this number. Let's write it. We said write an equation and divide on the possible smallest number. What will be our equation? Carbon will be 3.44. Okay, hydrogen will be 6.89, and nitrogen will be 1.72, and also oxygen will be 1.72. This is our formula. What I will do, I will divide on the smallest possible number. The smallest number here is 1.72. So divide all this by 1.72. Okay. When I divide the carbon will be 2. So it will be C2. When I divide hydrogen by 1.76, 1.72, it will be 4, H4. And when I divide nitrogen and oxygen by 1.72, it will be, of course, 1, N1O1. So this is my empirical formula. Okay. Okay, so like this we calculated the empirical formula. Okay. Okay, our fourth and last step will be calculating the molecular formula. We said to calculate the molecular formula there is an equation that we took in the fourth step. we said molecular formula is equal to the empirical formula, okay, multiplied by n. And we said that n, it is equal to the molecular weight divided by the empirical weight. Okay, the empirical formula, we know it. This is the empirical formula. Now we should calculate n. What is the molecular weight? We said molecular weight, it is given in the question, but here it is not given. Okay, here he is only want to know the empirical formula, so we will consider by giving that he gives us the molecular weight, considering it any number, and then we can calculate the empirical weight. Okay, the empirical weight, how we can calculate it? C2 12 times 2, it will be 24. 24 plus 4, 28. 28 plus 14, it will be 42. I think plus 16, it will be 58. Okay. Let's consider that the molecular weight is 116. So 116 divided by 58, it will be 2. Okay, so I will multiply the empirical formula by 2, multiply all this formula by 2, it will give us C4H8N2O2. Okay, like this is the molecular formula. Okay, so those are the 4 steps to solve any problem of percentage. The summation, we make sure it is 100. If it is not 100, we complete by oxygen. Convert percentage into gram. Calculate empirical formula by 2 steps. Calculating the number of atoms of all our atoms, including the oxygen that I added. And then finding the simplest formula by dividing the formula on the smallest possible number. And the last step is to calculate the molecular formula that is equal to the empirical formula times n. Molecular weight, it will be given in the exam. Okay, so let's try to solve the second one. Second problem is the same problem of percentage. When I calculate all this percentage, it will be equal to 100. So I will not add any extra thing. Okay, and it's giving you the molecular weight and it's telling you to calculate the molecular formula. So I should work with the same exactly steps. Okay, first step, all it is 100, no problem. Second step, converting the percentage into gram. Third step, calculate the empirical formula by first calculating the number of atoms, weight divided by atomic weight of all the atoms. Give you those numbers, writing those numbers in an formula and dividing the formula on the smallest possible number. It is the 2.15. Dividing all by 2.15, it will give you C2H6O. This is the empirical formula. But he doesn't want the empirical formula, he wants the molecular formula. So what we'll do, the molecular formula, we said it is equal to the empirical formula times n. When calculating n, and we said molecular weight divided by empirical weight. Molecular weight is 46. Empirical weight, I will calculate it from this formula. It will be 24 plus 6 plus 16, also 46. Pay attention. The two are 46. 46 divided by 46, it will be equal to 1. So n equal 1. When n is equal 1, so the empirical formula is the same as the molecular formula. It is very important. When n equal to 1, this means the empirical formula, it is the same as the molecular formula. So C2H6O will represent to us the empirical formula and also the molecular formula. Okay, like this, we finished our section. Like I told you, if you have any question, don't hesitate to ask. Okay, thank you.